After covering the main concept, or let's say the most important stuff in Python, today we will try to dive into computer vision. So as you can see this section here, I will just try to let's say postpone this, and I will come back to this after explaining some computer vision concepts. So in today's video, we'll try to see what is the image filtering and kernels. So before diving into this, please, I just would like to ask you to start this repo and also subscribe into my channel, like the video, and of course, if you have any question, just uh, drop it in the comment below. I will answer it definitely. So let me just control. So as I said, we will try to dive into image filtering and kernel. One, let's see, this is the core concept in digital image processing. Let's move it there. And we will explore how images are transformed and enhanced, combined theory with some quick examples. And this is only, let's see, as introduction to the image filtering, and we will see what are the type of filtering and everything. So in this session, we will try to see what is the digital image mathematically, what is the difference between image filtering and image warping, and what is the role of kernel in the image transformation, and also how the convolution works, key filters type, for instance, blurring, sharpening, and edge detection, and also real-world applications. So let's start with what is the digital uh, image. So digital image is essential as a grid of numbers. You can see here it's grid of numbers, and each cell here is called pixel. And the grayscale have intensity. The grayscale, we have grayscale images that have intensity value. Color images have red, green, blue values, and these numerical let us manipulate them as mathematically. And as you can see here, each image is represented as a matrix. Just keep it in your mind that it's like a matrix. And the grayscale images, it's only one two-dimensional array like this. For instance, this is only one example. It's, for instance, like this. It has rows and it has columns, and each cell here, as I said, it's called pixel, and the pixel value is from 0 to 255. If it's 0, it's black. If it's 255, it's white. This is called intensity. And in the color images, it's the same as a grayscale images as a matrix. Of course, it's represented as a matrix, but each channel represented with different matrix. For instance, we have red. This is, for instance, red. And we have also green. We have also another one is green, and another one, the third one is as a for the blue. So this is, let's see, the image, uh, how the image represented mathematically to apply, let's see, powerful transformation, for instance, using the filtering operations. And as you can see, this, for instance, thresholding, we will see how to do thresholding and everything. So never mind now. So now the transformation types is filtering and warping. And what is the filter and what is, I mean, the difference between filtering and warping? Filtering, it change pixel values like colors or brightness, but keep their position fixed. Think like blurring, sharpening, and you can see, for instance, as I said, this filter here, you have one image, for instance, this image here. And for the filtering, the each pixel will have, let's see, might have different value, different, let's see, intensity. But the position of the pixel will stay as it is. So it won't be, let's see, shifted somewhere else. This is filtering. Examples like blurring, sharpening, edge detection. But for the uh, Warping pixel is changing pixel position like rotating, scaling, but keep the values as the same. So let's see, this is the image, and in the warping, we will try to somehow rotate this image like this, and each pixel, the position of the pixel will change, but the value itself, the value of each pixel will stay the same. Examples as rotation, scaling, and distortion. And now let's move to the kernels. What are the kernels? The kernels, the key tool is the kernel for the image processing is the kernel, which is a small matrix, usually 3 by 3, 5 by 5, 7 by 7. I haven't seen more than 7 by 7 indeed. But most of the filters are 3 by 3. And this is, let's say, the blueprint of the for the transformation. It's identity, and also identity, let's see, identity kernel, which is no changes here. And if you, for instance, would like to have want to brighten the image, what kind of filter you would like to use? And we will see in the convolutional operations here. So let's say this is the convolution. This is the magic behind the scene. The convolution, you can see it in the it's a deeply in a convolutional neural network, and the convolution is a mathematical operation that powerful the image filtering. So I will just I have some values here. Let's see, short video here. I have already published it, and imagine this is the image here. I can put the link in the description below. So imagine this is the image, and we have a filter like this. Forget the filter now. What is the values in this filter? So the filter is 3 by 3, and the image is 1, 2, 3, 4, 5, 5 by 5, for instance. Now, what is the filtering or convolutional is doing? I will just skip this. Let's see, and you can see here the filtering is for the image. It take 3 by 3 as the filter size. If you have 5 by 5, you can have 5 by 5 like this. I mean, this is the whole image indeed. But what are the image filter here is 3 by 3. Now I will try to put it. Let's see, just imagine as you put it off over the image itself. And here, if you see, I have 3 by 3, and I will try now to multiply this by the first value plus 9 times minus 1 plus 7 times 0 plus, and etc. As you can see, this is the formula here. And the last, after summation, after the doing the calculation, the pixel size, the pixel value will be minus 12. It will be in this one here. And next time you will move one, let's see, one pixel. So the last time we was here, now we here, now we will move a bit one time. So I will do the same calculations and do the same as you can see here until we have this is called a sliding window. After let's see covering the whole pixels, this is called the convolutional array. Let's see, convolutional, which is used in most of in all of the filters. Let's see, for instance, object detection. I mean, edge detection, sharpness, and everything. We will see also this in examples. And here you can see now the type of filters. Where's the type of filters? Uh-huh. So this is, for instance, a blurring and a smoothing. So the blurring is trying to reduce noises and smooth the details by averaging pixels. For instance, Gaussian blur is popular for its nature look. And don't worry about this. I will try to give you a real and numerical examples of each filter in the next coming videos. So if you don't understand this, It's just to give you an overview what is the what's going on here. And the sharpness here, the sharpness, it's enhancing edges by increasing contrast between the adjacent pixels. It makes detail, let's see, clear. So you can see here, this is before, and this is the sharpness. It's somehow trying to showing this, uh, make it sharp. And as you can see here, this is sometimes you have fixed filters, sometimes you have fixed value, but we will see why and how these values, let's see, are, let's see, created, or let's see, generated. For the edge detection, I think edge detection is trying to find the boundaries with the pixel intensity change rapidly and revealing objects structure. So, and you can see object edge detection is useful for the object detection, feature extraction, and also it's called edge detection. It's used in many algorithms of the computer vision. And the Sobel operator, let's see, is the classical horizontal and vertical edges. So we will see what is the Sobel operator. We will see what is the Canny and how the Canny is working, and also Laplacian algorithm. For the real world application, you can use it for this medical imaging, which is enhancing MRI and CT scan for improving diagnosis. So if you can see you have some images and you would like to enhance the MRI to detect the structure of the image, and so you can detect, for instance, what are the disease in this, for instance, specific region. And also it's used in uh, remote sensing, processing satellite imaging for environmental monitoring, computer vision in object detection, facial recognition, and also anomaly detection. As I said, I will explain. I will show you what how to improve, let's see, anomaly detection algorithms, and also for the artist effect enhancement. Sometimes you have, let's say, you have an an image, let's see, pie and painting, and you would like to see if it's real or not. So you can use, for instance, image processing, enhancing, sharpening, and to see if it's real or not. And I think it's now we've finished this. And of course, if you have any question, just drop it in the comment below. But as I mentioned at the beginning, we will go through each pixel in a more details with examples, with real, let's see, numerical examples, and also with the Python code. Thanks for watching, and see you next time.